Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
That was mostly for them. So, welcome. This is no longer the social media colloquium or the MSRNE colloquium. It's sort of more fun in between. A chance to bring somebody that we've been engaging with all summer around social media. This is basically Mark's identity is about in-betweenness, which he will happily tell us. But Mark is here today. He is both a professor at the Michigan I School as well as a visitor this year at MIT, although he's about to leave, and I think there's deep sadness in the room. And he's
me included, yeah.
He does a great job of bridging between a lot of social sciences and computer science, and so I will let him tell more about his own work.
Okay. Hi. By the way, if you're sitting over there, you have to answer the question. So just to let you know. I actually have I'm at the University of Michigan. I actually have a true joint appointment actually in computer science and in the School of Information, so to correct the record. And someone reminded me of some of my previous work. I'm actually best known as the bouncing fruit algorithm person in Miss Pac-Man. Okay, so the question today is, why is social computing so hard? And I'm going to say it's because there's a gap between what we know to be technically working and actually what's socially workable. Some of you have heard bits and pieces of this, if not the whole talk. This follows an old paper of mine. But basically what I'm going to do is just go over some of the social findings actually from CSCW and social computing, and then I'm going to talk about the Project for Privacy Preferences project, something like that, and at the W3C as an example problem. And then I'm going to walk through just a little bit about the technical understanding of the social findings, and then talk about maybe some of the things that we can do, and kind of end on kind of a call for action, as it were. By the way, I love questions in the middle. I should ask who's in the room. So I recognize about a third of you. So how many of you are social analysis people, whatever that means? Okay. How many of you are theory people, whatever that means? Notice it's computer science theory. Computer science theory. Okay.
Theoretical social analysis.
No, I said computer science theory. I learned that from Rob Kling. And the rest of you have no identity, or you're at the... Okay. Systems people. Makers, systems people. But you don't make systems, you make other things, or... Okay, cool. And the rest of you are just, it's cool in here, and you figured you'd come in out. Cool. Okay. So I got a real mix of people, which is going to make this very hard. So the social people are basically going to zone out through this part. The technical people will probably zone out through this part, and hopefully I'll wake you all up by the end. If not, enjoy the view. I was actually thinking maybe doing it from that podium so I could look out, but apparently I don't get to do that. Okay, so what we'd like to know is why trying to technically augment the social world is so hard. And it is hard. We don't have a very good understanding of how the social world works, and we certainly have less of an understanding of how to augment it technically. Many of you in the room have worked on this problem as long as I have, and maybe even better. And probably everyone would agree with this. So the premise that I'm going to have is that basically we understand at least part of what we have to do, but we, meaning technical people, makers, systems people, can't deliver what we know we have to do. And I'm going to call that the social technical gap. And I don't remember whether I said I like questions in the middle, so feel free to ask questions. Okay. Now I'm repeating myself. So is this controversial? No, but it has really important implications. And just as a side, I'm going to say CSCW a lot. This is my main field. It's computer-supported cooperative work, or collaborative systems, as part of human-computer interaction. And it's somewhat the same, almost the same as social computing. So there are some important differences. Dana, wherever Dana went, probably thinks of herself as a social computing person, but not a CSCW person. There are probably people in the room that think of themselves as CSCW people, but not social computing. But for all the theory people, don't worry about it. It's the same. Okay, all the social computing people and CSCW people can pick at me later about my throwing them all in together. Okay, so what are some findings? And these are, so I have a paper that goes into many more of these in gory detail. I'm just going to do a few of these because otherwise you all fall asleep. The argument is, why is social stuff really hard? And so one of these is that social activity is very fluid and nuanced. The details of interaction matter, and people do it with great agility. So I'm standing up here, and I sound like a professor probably. I go home, I do this with my kids. Very bad idea. They don't like that. My wife likes it even less, right? So, you know, I have to carefully weigh who I'm talking to when I'm talking to them, who exactly I'm talking to, right? So you can think about who you actually discuss the, you know, potential job moves later, right? It's very, very nuanced, and again, it's very fluid. Computational systems are truly awful at this, right? When I'm talking, I don't look at you and turn around and do my access control and then come back. That would be really strange. And yet, we think that computational systems should kind of do that. One of the things this leads to is it's sometimes easier to augment technical mechanisms with social mechanisms. If you sit all the way over there, I can promise you won't see me actually point very well. But I promised anyone that sat on that side, by the way, they had to answer the question of why social computing was so hard. Okay, but anyway, so the idea is that a lot of times social mechanisms like back channels, communication channels turn out to be actually really useful because you can do that kind of nuanced behavior in a communication mechanism that you can't do in some more hardwired technical mechanism. Another one is that there are multiple goals and conflicts among individuals in any social setting. These are often hidden, they're not well articulated. Sometimes they can both exist and not exist all at the same time. So think of a typical software engineer, right? They're going to say whatever's best for the company. And yet at the same time, you always want to learn the new thing. You want to be doing new tools because they're going to help you in your job. You may be fighting with other people about the architecture of a system. These aren't always shared understandings, but somehow the work gets accomplished. So we're really good at resolving breakdowns as people. Systems are notoriously bad at that. One of the things this leads to is something called boundary objects, which comes out of Lee Starr's work, which boundary object is essentially an information object that as it crosses some organizational boundary, it loses some of its context. So an example would be a payroll record. Right, so if you're in a mortgage company, you don't want to know about all the problems with the payroll record internally. You just want to know if the person gets a paycheck, right? But inside, it might really matter what the details of when they got certain benefits were, or the other kinds of gory details of when they actually became, say, a employee as opposed to a probationary employee. Information loses its meaning as it crosses those boundaries and has to be recontextualized. And one of the things that's interesting about kind of the social world, again, is that we're not very good at figuring out when information should be decontextualized and then also when it should be recontextualized and how to recontextualize it in a way that doesn't dump an immense amount of detail on people. You guys are dead quiet. Okay. This is the part in the movie where there's no jungle sounds anymore. Something bad is going to happen. I'll wait for it. Okay. So a lot of times we need to negotiate the meanings. So again, one of the things that's problematic even in AI systems is the idea of negotiating meanings. We often use some sort of communication mechanism for negotiating those meanings over time. It has to be what Strauss calls a common enough shared of understandings, or shared understandings. It doesn't have to be a perfect understanding. The way that the social world works is usually just good enough understanding. And again, that'll lead to breakdowns. Okay. Exceptions are normal. Normality is exceptional. You probably all knew that, right? Okay. I'll start doing a dance in a minute. So one of the things that Suchman points out, and actually it's kind of echoed in the software engineering literature as well, is that a lot of organizational life, a lot of social life is based in trying to get things back to normal. So things are done in companies, the paperwork isn't quite right, and people spend a lot of time trying to get it back into the right form. So in software engineering, what this looks like is we teach people a set of canonical software processes. Why do we do that? Not because the world is perfect, or that you're likely to be perfect, but so that you at least know how to get back to a normalized social form of some sort. This also carries out in kind of social role. So a lot of times roles are fluid and informal. That is, someone goes on vacation, someone covers for them. I'm a professor one day, but I can be replaced, hopefully not too easily, but at least someone can take my lecture. Right? And so again, one of the things about computational systems we know is they're not very good at this part, the informal part, so workflow tends to break at that. And the exceptions are actually quite difficult in most computer systems, right? We try to jam things into a standard form. Just a few more of these. Another thing that...
We do that in society as well, right? In many ways. Right, we sort of have cars driving in the direction of the one-way street, and you have to drive on the right-hand side and not allowed to drive on the left-hand side. And sort of after a while we come up with all kinds of rules to sort of live together. So I think that trying moving things back to normal is sort of part of life as well, right? We have the wild 60s and then eventually decided maybe we want more regulated relationships and whatever.
So
that's what we have.
So, okay. Things like routinization, standard operating procedure, rituals are standard parts of social life. And to make things normalized, or things can serve as resources because in people's lives because they can become easily understood very quickly, right? So you can think of them as typifications, I think, in social terms. Computer stuff is much, much worse than we are at doing this, right? So I can understand a wide variety of ritualized behavior that's essentially the same, and a computational system would have a very difficult time with that. So the point's well taken, but I'll still claim that the social world is much more fluid and nuanced than computational systems. Another finding that we do a bit, at least, is that people want to know who's around. So the most famous study of this is in flight control, air traffic control. So the way that a lot of air traffic control is arranged is people sit in a line. And the reason they do that is because out of the corner of their eye, they can see that that person's getting busy. And that means the next person will get busy eventually, and then I'll get busy. And so you get just a little bit of additional information by doing what's called peripheral awareness. If you don't think that this is important in computational systems, you might think about the last time you worked with someone at a distance and they weren't delivering on time. Right? You start to get really angry, and then you realize that they've been up for 3 days straight trying to get some block in the system through. Right? And it's because you can't actually see what they're doing. The visibility also leads to learning. So Ed Hutchins has done some interesting work with airplanes again. You know, it's completely possible to have a one-pilot commercial aircraft, right? And as he points out, the problem with the one-pilot aircraft is not fault tolerance is bad. You know, if someone has a heart attack.
You never learn how to fly.
Pardon me?
You don't learn how to fly.
Yeah, exactly. Right. So where do you learn how to fly? Right? You got to learn from other people who are experts. You can learn in a simulator, but it's not quite the same, right? You don't get to see the range of exceptions. So one of the things about visibility and awareness is that you actually do some learning. And again, computational, this is a real kind of different slant at the social world, but one of the things that happens in the social world is we learn a lot from watching other people. And computational systems, again, are not good at that. And there's a trade-off between privacy, awareness, I think that's visibility, rather than visibility, and disturbing others. And I'll come back to that a little bit later. And I have two more. The norms of use are negotiated, and the norms are being constantly renegotiated. So one of the things that's hard in computational systems, again, one of the things that makes social computing hard is that it's not a shared set of understandings from the very beginning and then you're done. Things are going to mutate and change over time. And so let me skip to this. And so people not only adapt to their systems, but they also adapt their systems to their needs. And they do this over time in a very slow kind of way. And this can be everything from categories to the kinds of typifications that we just talked about, standard operating procedures. But this is usually called coevolution. And I'm going to come back to that a little bit later.
But our systems are not very good at being adapted.
No, they're not. Good point. In fact, one of the areas of social computing and CSCW that's the most interesting is tailorability and end-user programming, which is kind of one of the more minor parts of computer science, but it turns out to be really important for group use, especially group use, right? So for individual use, it might be important, but groups are often going to change over time. As new people get added, as they start to understand what they can do, you want to do new things with the system, and the system may not be flexible enough to do it. Yeah, good point. Okay, so not every social computing researcher would agree with these. By the way, if you didn't understand one of those, this would be a good time to ask a question. Again, you guys are like dead quiet. Except for David, who's being very good.
We're respectful.
I like being respected. That's good. I like you guys talking more. Okay, but in general, these are standard assumptions in the field. And these go back, some of these go back 50 years in the social sciences. They certainly go back 20 or 30 years in social aspects of computing. And not every system is going to fulfill these.
So when you say standard assumptions in the field, does that mean, I mean, you have given examples of airplanes and sort of the, what I would call the old-fashioned CSCW? Sort of this part where you learn how to, where you see how fast people type on a keyboard and things, sort of.
That's like old-fashioned HCI, not old-fashioned CSCW,
Well,
but.
So is that really, are these assumptions really widely shared, sort of, would everybody between 2000 and 2010 agree on those?
I think so. You may disagree with me, in which case you don't agree, and therefore I'm wrong. But everyone's a big claim. But I will say that they're generally believed. So I mean, I think that CSCW and social computing, the stuff that I presented isn't very controversial in the field, I think. How to deal with them is controversial. But I think they're pretty standard social findings now throughout a range of the social sciences, and including CSCW and social computing. Yeah.
But they apply to more than just computer interaction.
Absolutely.
It's all social. It's really just rules for how groups work together, almost, from what I can tell.
Yes. So you could apply them to a large range of engineering problems. Social settings. I think that they have particular meaning with computational technologies, and the rest of the talk will head in that direction. But yes, and there, strangely enough, there are more studies than this in the field. So a lot of the studies that show up in the research conferences tend to be detailed studies of many of the things that I presented. But I don't know. I have a bunch of CSCW and social computing people. Anyone want to dispute any of these? There you go. By the room consensus, everyone agrees. Okay. Now, the argument is for a working system, you have to ignore some of these. So basically, I'm going to now claim that the difference between technically working, right? So we know from these things what we need to either organizationally or socially find workable. We know a set of requirements. But the problem is I don't actually know how to do them technically. I don't know how to fulfill these. And that gap is going to be the really critical thing in understanding why this is such a difficult field, and also I think why it's such an interesting field to be in. Okay, so how do these get played out in practice? I'm going to use the Platform for Privacy Preferences project, which I was associated with for a while, as kind of an example. How many of you have actually heard of P3P? Got a few. Okay, so this is why you don't have to worry about privacy anymore in the internet. So this was an attempt, 1997-ish, to Lori Craner, who's now at CMU, was the lead on this, but there were people from Microsoft and IBM research and a number of other people, number of other groups in this. It was a W3C effort. And the idea was basically to label personal data, largely in a web environment. And the idea was to help people reach informed consent about services. And the idea is that you send a machine-readable proposal, and the service declares its identity and privacy practices. And this was all done in essentially a computational statement. The critical ingredients of this were that user agents were going to be able to parse this. If there was a match between the service practice and the user preferences, an agreement would be reached. And you should be able to deal with things if the user agent would be able to deal with potentially objectionable practices. What do you think?
It's working really well, isn't it?
Yeah. So, you know, the reason I bring this up is not, I mean, I think this was a really interesting effort, and certainly Lori and other people are to be applauded for trying to do some of this. The problem is it broke down in practice. Right? So this was actually just too hard to do for the kinds of computational mechanisms we had, and this is actually where I started to develop some of this. So I went in, to this project, you know, I do both technology and social analysis, and so I went in basically as a technical person working on the project, and kind of, you know, I was kind of following Rob Kling, who was one of my senior colleagues out at UC Irvine, where I was at the time, and I was waiting for the technical people to just hammer the social world. And what I found instead was a bunch of people who really understood it really well, but didn't know what to do about it. And that's, I think, where we actually are.
But you said it failed because of technical issues?
Yes. Well, I mean, there were adoption issues as well, but I think it failed largely because of technical issues.
Can you explain?
Right.
Okay.
That seems contrary to what you were saying before, which is that we should understand the technical stuff, but then can't get it to work in practice socially. No, it was the other. We understand the social world and what we need to do, but we can't figure out how to implement the technology to do it. I'm pretty sure I said that. If I didn't, I should have said that. We know how to implement technology, but not the right kind given our social understandings. Okay.
Even if you could implement the technology, that doesn't mean that it would be adopted. So, I mean, you might say you have to do the technical first and then see whether the social part will work.
So I can't say that if we had the perfect technology, this would have been adopted.
Right.
But I can say we didn't have the perfect technical.
So, but let me try to understand. How do I understand? I mean, I can think of having a system I write specs, and then it's too hard to build the system. Or
Give me 2 or 3 more slides and come back to me, okay? Because let me explain what I'm saying, and then you can hammer on me, but let me at least explain it first. So some other stuff, so you should be able to configure agents to do agreement. People would not need to read the privacy policies at every website in order to use the web, okay? And then something that was dropped, which is really important, is that if an agreement was reached, your data would be automatically transferred, right? So I feel particularly proud that I put the stake in this one. But what's the problem here? Actually, this will go to your question. So how many of you would agree that you're going to have some little AI floating around in your world, and whenever the privacy policy on some website matches, all of your private data will just get transferred?
Because the collection might reveal information that the individual elements don't.
Okay, so
It's
one
not
is...
even that, it's context, right? I mean, the context could be totally, what is that?
They may say the
I mean, it's
policy
totally
is one thing, but
context.
it may be real.
No, but
They could be lying.
Okay, so
I mean,
I got a aggregation problem, I got a lying problem,
context.
socially nuanced problem.
values.
How many people think that this thing would work? Like, you could have an AI that would just know whether or not your medical data is...
Does work mean, could you steal all my data? Yeah.
Okay. So here's an interesting HCI problem. It's also a CSCW problem, social computing problem. So the information space is horrendous. Okay, I've got every piece of data that I own and every person I might want to give it to. Right? Big space. Okay, now, unfortunately, it's not just a two-dimensional space. It's an eight-dimensional space as envisioned by P3P. By the way, which is not something that my mother, who's about 80, can understand because she really doesn't do eight-dimensional spaces that well. But things like who, what, intended use, duration of use, right? All those things go back to what you were saying. Those are the nuances. Those are the context that's really important. Right? I might be willing to give you the data if you promise not to give it to anyone else, but then I really want to know what who somebody else would be. Right? So this was an interesting thing. So there's a category, other companies, my own company. Right? I might trust Microsoft to protect my data. I hope that wasn't the Microsoft people laughing. Right? But, one of the interesting things about P3P is, let's say that I'm an affiliate company and I pay Microsoft $1. Well, let's take it out of Microsoft since I'm here. Pay Amex $1 to become part of their network of companies. Right? So am I now part of that company? Is it separated? Am I, as a person, going to really be able to look through enough of the privacy policy, which, by the way, was in a formalized language, to kind of understand that? What would it mean to actually make that thing work? I'll also argue that one of the things is that privacy is critically important to people. Right? You get it wrong once, people don't come back to the system. Right? Unless you're... Yeah, but you can think about what's actually known maybe in a web browser as opposed to Facebook, right? So I maybe can figure out whether or not you have some disease from the kinds of things you have in your system. It's a very highly nuanced thing. I really, to go back, I really want to make the comment. It's very situated. I really need to weigh whether or not I give you data as opposed to you data. I might want to give you slightly different things. And by the way, this is just an everyday activity. People do this all the time, and they don't think about it. I protect my privacy when I'm walking around, right? I don't shout out my medical data as I'm walking down Main Street. That would be kind of strange. Although I think I met someone like that on the T earlier today. But
so
yeah.
What you're saying in bringing in the medical is exactly the area I've been working in. So one of the aspects is you're dealing sometimes with a time factor and a delayed evaluation. So people would be willing to share certain aspects of their lab reports unless they're positive. So the information changes
That's a great example.
over time.
Yeah, that's a great example. So I haven't even considered that. So think about it as even a snapshot problem we don't know how to deal with. And then there's many things about privacy that are even more nuanced than this, where it changes over time. And now privacy is a particular problem. I didn't actually want to get into that, but trying to recall data is not possible in the U.S. It is in parts of Europe.
It's also a calculation of what you can gain and what you might be able to lose. Right? And that calculation you're making based on your understanding of how far it can go. So even say something like a medical data, right? You may be thinking about the things you could lose. You might be able to lose insurance. You might be able to lose face in particular ways. But if you have a very rare disorder where the possible gains of finding anybody else with that illness who might be able to give you information, running around and screaming it on the T may be a very effective way of achieving the goal of the possibility of finding somebody else.
But so I think I know where you're going, which is the win in social computing, because I'm really just talking about the negatives. But remember, there's this two-dimensional space, everybody that I might do and what data I've got. So what you're saying is, but I would still probably choose who I'm broadcasting to rather than just broadcasting indiscriminately, or at least many people would. So
I think if you can, you would rather choose. But if you don't have the ability, if it's a matter of indiscriminate or not at all, there may be something to be gained by indiscriminate sharing instead of if you don't have the opportunity for discriminate sharing.
Okay, so I would argue that the only change in this, your point's well taken, but the only difference is that you just gave me a different kind of nuance.
Fair.
Right. So I'm making some set of decisions about who I'm going to provide the data to, which maybe is everybody in this particular situation, because I'm making some decisions about intended use and other kinds of things.
I think basically there's a big space where you can say that there is a net benefit to providing this information, and then you just do it. Once there's a loss to providing the information, you have to weigh it against all the other aspects, and it becomes much more nuanced.
Yeah, and just
if you just think about the beneficial, the information which there is generally a benefit to provide, but these issues still come up.
Yeah, and just to drive the point into the ground, what I would say is we do this all the time, and we think about who we're doing it with, and programming that into a set of access control rules or rebacks or whatever is not something that most people can do and rely on all the time. Right? So the problem is while we understand more or less what people do, and by the way, we don't actually understand how privacy works very well with people. I think you'd agree with that. Trying to get a set of policy mechanisms to work correctly is even harder. I'm going to come back to that because that's one of the projects I have going now. Okay, so the argument is 8-dimensional space, interesting HCI problem, by the way, reduced in some browsers to red, green, and yellow, which I would claim is a problem. But most people really can't deal with the 8-dimensional space. I don't deal with it very well myself. And trying to do this reliably is really important to people, but really hard to do. And I already said everything on that. So the argument is that the P3P problem, to go back, there may have been an adoption problem too. It was a fascinating project to watch for a variety of organizational and societal reasons. But just from a systems viewpoint, the system didn't offer sufficient nuance. It was really hard for people to write their own their own privacy statements adequately. It was very hard to know what the language was and what the nuances were in the language. The systems weren't socially flexible, so they didn't change state gracefully. The user agents weren't able to do that. We just talked about a lot of that. And one that we didn't talk about is systems don't allow sufficient ambiguity a lot of the time. So I don't often tell people whether I'm telling them something or not. I just don't bother to mention it, right? And systems have to be very explicit a lot of the time. So I would probably have to tell an external client that I was not telling it something. And that's not what we normally do. Okay, so what I was trying to point out is the bottom line. There's a gap between the social requirements. I just walked you through. Everybody, I think, got it in the room, or at least you were nodding your head and not looking out the window or whatever. But if you know how to implement this, awesome. I'll give you a research assistant, no problem. Okay, I don't think we know how to do that. You're volunteering for the research assistantship? Cool.
I think it's not just an implementation problem. I really think it's a concept. We claim we understand it because we intuitively have some idea how people do that, but I would claim we don't actually understand how people do this.
So I would claim that even if we knew how people did it, we wouldn't have the technical mechanisms to do that because there are too many states mapped over the top of one another. There's too much ambiguity in the way that we work, and you would not have, I'm going to talk about this a little bit later, but we don't have the input, as it would, to be able to understand what state some user is in. I'm going to get to this in a minute, but I don't think the von Neumann machine is capable of doing this. And I don't really know why. I just have an intuition of that, and I'm willing to debate that. But I don't think it's just getting the perfect spec, because we've had 2,000 years to get the perfect spec on privacy. I'm going to go for historical argument there. If you can do it, feel free. I'll give you an RA shift, no problem.
Too hard to formulate the specs. That's what I'm saying. I don't think it's, but I think.
By the way, I picked a really nasty. Privacy is probably the worst problem I've ever worked on, in terms of this, and I picked it because it's a really nasty problem. There are other things that the argument probably comes closer to what you're saying. Okay, so one possibility.
You're going into the two possibilities now in more detail?
Yeah.
I thought you were going to tell us which box you're going to check.
One from column A and two from column B.
Yeah, I'll give you. They do kind of look like that, but it'll be that one. So, okay, so one possibility is the technical people just don't get it. You know, if we had the perfect social specs or social understanding, we'd be able to do it correctly. And the other is we get it, but we really don't know what to do with it. And I'm going to use, as an example of this, a really nice paper, which is actually Marwood and Greenberg from '94, which is a interesting discussion of concurrency in CSCW systems. And it was actually just doing some very simple group graphic editing and saying why distributed algorithms work just fine. We know how to do it in terms of the distributed computing, but we don't know how to do it in terms of what people actually want. So think of people adding letters or drawings, and the problem is that, you know, if you don't have some level of concurrency control, locking or whatever, the group is going to become confused because the displays are inconsistent. But the problem is that the coarser the lock, the more difficult it is for people to work closely together. Right? So you get into these latency problems of if you lock too much of the document, right, it's fairly easy to implement, but people get really upset. And if it's too fine to grain, then people have to switch roles. So some of the earliest CSCW systems, social computing systems, for example, did something that they called explicit floor control. I had to ask to be the speaker. People hated that. They just hated it, right? Because it's just really awkward to do. I know how to implement it technically. It's simple to implement that technically. The other possibility is everybody talks over the top of one another. You know, I'm sure that you've been in communication channels where that's the case, right? And trying to find something in between is the really hard thing. So what I would argue is that technically, you know, the technical people understand the problem. It's really just a matter of we don't have the perfect kinds of technical capabilities to solve the problem. Usually somebody explodes at that one. Okay. Some other examples, these are just simple examples, is Kaplan Systems from 92 to 98, which were, actually this one's a great one. So you build this communication protocol in Lisp, Emacs Lisp. Right? All of you guys are really good at doing that, right? So that's how you would normally converse when you talk to your parents or wife or significant other, right? And the problem, of course, again, is it's just kind of awkward. So we know what we're trying to do, but we don't quite know how to do it.
But you've also talked about, you know, your mother before, and I think we've talked about our mothers. So, you know, this issue of talking over each other. I mean, that's actually something my mother would really understand. She'd understand talking over someone. Tell me more about your mother.
I could use my sister instead if you prefer. I'll take that offline. Okay, so what I've tried to do, at least so far in the talk, I'm running a little bit late. How long do I have, by the way?
5:30, including Q&A.
Okay, so this thing was aimed at 45 minutes, but it's probably going to go like an hour. So what I've tried to do is establish, at least at some level, that there is a gap. There's some really important social considerations that we need to think about, and that we have some fairly decent handle on those requirements. I've tried to at least indicate that we're not as good at creating technical mechanisms to actually facilitate those social requirements.
Actually, let me question that, because in the examples you've been giving, we're sort of able to articulate what's wrong with a system, but that doesn't necessarily mean we can describe what ought to be.
I'm not sure I understand.
So when you say we have a handle on the problem, we know how it should be, right? So you know, you've been giving these examples where we have systems where we can say, yes, that's wrong, that's wrong. But so being able to carve out things that are wrong is not the same as being able to describe what's right and what we ought to.
Yes. So in some sense, we have an existence proof. You're able to walk around in the world and, you know, people don't shoot you.
Yes, that's right. So, but it's not clear that we can describe exactly why it is that I'm able to walk around in the world. We're able to describe why such and such robot is not able to walk around. So we have a separation that says that's no good. That doesn't mean we can explicitly describe what it is that allows me to walk around.
Yeah, I would agree with that, but I think this goes back to, you know, computational systems require an explicitness that's past what we as humans actually need. Somehow we're able to learn social rules or social norms in a way that's very difficult to program.
Yes.
And so that may be part of the problem rather than why we have the problem.
That's right. I mean, you could argue that what we need are systems that require less precise specifications, which would take us out of the realm of programming. But I just wanted to sort of poke at this idea that we really know what the systems ought to be. Right? I mean, I don't think that it's a matter that we know how. Okay, fair enough. It's not clear that we know what they ought to be. We certainly just. It may not be a specification problem. It may be that we honestly don't know what they ought to be. We can. It's whatever. It's the opposite of that obscenity thing, right? We know it when we don't see it, but we may not be able to explain what it is.
So I don't actually have a good answer for that. I mean, I think that's that is the essence of at least part of the question. So my intuition, which has been formed on 10 years of thinking about this, is that the von Neumann machine, whatever that means, is... So the problem isn't just the I/O portion of the von Neumann. It's not the digital part. I'm not quite sure where it is. We seem to be able to walk around as some sort of computational system in the social world and be able to function just fine most of the time. I mean, there are strange anomalies where, you get into trouble. You end up in the... I don't know, for me, it's ending up in the wrong part of town and missing the danger cues or whatever, right? But I at least know there are danger cues, right? Computational system, right? I could build a robot and it would happily do whatever it was going to do, right? And they're really fundamentally different kinds of machines, and I'm not sure I can articulate it past that. I think it's a really interesting question of what a social machine would look like. So one of the arguments is that, the magic solution is going to be around the corner. So we'll just come up with the perfect specification language, we'll come up with the right machine, and the only thing I can say is we've been doing this for 40 years. If one of you has it, we'll be happy to chat. But I don't see it. The other possibility is the coevolution problem. This goes back to what I was saying. So we'll just change, and the systems will change, and we'll all be happy afterwards. In its extreme form, this is Taylorism, right? We'll just become rational just like the machine. And there's a tension with the assumptions in HCI. This is almost a religious argument. So HCI does not like the idea of we're just going to evolve to be the machine. The idea is instead to kind of do what Neil Postman has argued, is having people think about what their future world looks like and not going just for the rational. And I'm going to limit it at that. The social computing is kind of interesting because there's this mass market effect where actually there is kind of a coevolution going on with a marketplace that's interesting with large-scale social computing systems. Right? So something like Facebook. Chris, you were supposed to yell as you left. So I'm going to argue it's kind of time to move on. There's been, actually at this point, probably closer to 40 years worth of social research and technical research. We don't have all the answers, but we have some indication what the answers should look like. I have a series of papers that talk about ideological and educational agendas. I'm not going to go into that here. There are lots of these ideologies of how to fix the problem in terms of political action, so the Scandinavian School of Design or Taylorism for that matter. And I'm just going to kind of point towards my papers on that. What I want to talk about instead is the science of the artificial. So how many of you have actually read the science of the artificial? Time passes. This used to be standard in computer science to read, okay, particularly artificial intelligence. So this is Herb Simon, at least. More of you nod your head even if you've never heard of him, because it's really important to be able to know who he is. So this is kind of one of the demigods of AI and economics for that matter. And the argument, it's a very provocative argument. The book's actually not that great. It's cobbled together from a series of lectures, and it's admittedly not coherent. But the argument is that computer science is a synthetic. So as opposed to the social sciences or the natural sciences, which are analytic. We take apart the world and we figure out how it works. We're in this great and interesting place. We make up our own world and then we study it. It's like permanent lifetime employment, right? You just have to create something new and then you get to study it. And he argues that this is one of the interesting things about engineering. Engineering not necessarily done by schools of engineering, because he claims schools of engineering are applied analytical schools, right? We teach people how to model things. But synthesis is about design and making something new. And so the argument I'm going to make is there should be a science of social computing. Why? And I'm going to call this artificial sociology, although that's a horrible term. And the question is, what would we, how would we go about designing these things? What should the machine look like, right? What should the what do we need to know and understand about the social world in order to be able to design successfully for it? And so, and again, I think we're kind of starting down this road. So when can we successfully ignore need for nuance and context, right? We do that all the time. I mean, I use keys. They're not the most, it would be much easier if somebody let me into my house every day, right? But somehow I use artifacts to deal with things. And when can you augment human activity with computational technologies in a way to make up for loss in this nuanced and context, right? So when, to put it in Jim Holland's terms, when can we be beyond being there? So, do we take best practice from engineering disciplines? Do we consider what kinds of future resources or future research will solve some of the gaps between the technical capabilities and what people expect? And then how can we systematize these to try to understand them better? I think this is one of the things that makes this field really interesting. So I know probably all the theory people are going, oh my God, social computing, what is that? But I actually think this is the beginning of a really interesting science. And it's because it's not social science and it's not technical work. It's something that's different from both of those. And it really is a science of the artificial. We're making up brand new worlds. And we need to understand the basic principles for doing that kind of design.
Math too, right? We make up, when I do math, I make up an artificial world. And then I say things about it, right?
Okay.
So, I think there are
some parallels in this.
There are some parallels, right?
Fair
I'm not I'm not describing the natural world necessarily when I'm doing math, right? I can make up something and then
yeah. So this might actually be a little less artificial because we have to be somewhat. I think that's a great point. So. And I haven't really thought about that very much. But, in some ways, the social world, there is a social world out there that we have to remain somewhat true to, right? So I can't get people, to do completely random things. There's ranges of what we can. They are a design constraint. I saw a hand over here.
So what I've gathered from this is I'm not a computer scientist, but I'm more in the social field on the other side. But I look to Louis van Aan, and is this kind of similar to that? He used kind of human computation to learn, how we recognize things in pictures and in audio. And is that maybe possibly a way that you can kind of solve this problem? Have something that is almost a constantly learning device to learn how our social systems are working and constantly.
So that would be one attack on that kind of problem. So to the extent that you would generalize games with a purpose, which is what he's doing, you would have part of this understanding, right? It's not the whole world. Yeah. So I think computer people tend to find one solution and decide that it's generalizable to the entire universe. But I would say that that's an interesting attack on a set of issues in this world.
Because isn't that basically, it's creating an artificial world that is similar, or is trying to grab some similar properties and some similar constraints from the real world?
So, to the extent that he's trying to understand the social world and he sees it as what's sometimes called a technical probe in HCI, then yeah, because he's trying to understand what the social world is through these computational games. And at the same time, he's designing in that computational medium, as it were.
I would focus on that sort of designing aspect. It's not, you talked. I hadn't heard of Taylorism before, but the idea that that people are going to evolve is questionable. On the other hand,
you do know Taylor is the people work to role. Taylorism.
Yeah, so you think I'm a social scientist. But when you start talking about social systems, I mean, we know that you can engineer societies, like not Rand, but like Louis Fonon's work, that he's engineering a kind of social interaction that wasn't necessarily there before, and so so that kind of social engineering or social system engineering seems like there's a ton of opportunity there, but it requires a science to underlay the engineering.
Judith, I think, wants to come in on that.
It also seems that defining what's a benefit is really, really difficult. To take a different thing that calls itself a science, there's like traffic science. And it seems like if you want to get rid of congestion, you add some lanes to the highways, and it's turned
or you
out
remove them.
Well, right, exactly. It's turned out that often when you add lanes to the highways, the congestion gets worse, and people's behavior was very, very complex. Whether taking the lanes away is a benefit or not, you have to think about what your benefits are, because you can reduce the congestion, you can reduce pollution, reduce the number of people driving, but you had to at some point be adjustable enough to say fewer people driving is a benefit, not a loss. And with most of these issues that we're thinking about here, the question even of what is a benefit is very hard to define. There's, for instance, if you look at, since Facebook has come up here, it's an obvious one, a lot of times it's simply in the design world, the audiences have very different benefits. So for instance, the audience of advertisers versus the audience of users versus the audience of people who own the company and want to sell for a profit make all have very, very different definitions of what is a benefit. And then for the social side, where let's say we'll concentrate on the users, that's where a lot of the coevolution happens, where in using things, something they had originally thought was horrible turns out to be very useful. So that seems like it's a big piece of the question, not simply...
Well, so I'm just going to say yes. So I think you described why I personally find this to be an interesting problem. It's a messy problem. There are multiple goals that are being solved simultaneously. It's a political, and all the meaning of that word, set of resolutions. They're probably ambiguous resolutions at best. They're partially shared resolutions to those things. Things have unforeseen trade-offs that come back later, right? The positive test scores is an example of that. We certainly, I always found it amusing that MIT had a department of traffic stuff here, because it seems like, Boston is the last place to study this. But, I think traffic might be another one.
Yeah, I think so.
It might be a great place to study it. It's certainly not the place that you do engineering on it. But
doctors do go to hospitals to study sick people.
yeah. So, but I mean, I think all these things are really interesting artificial sciences in some ways. I just happen to think that social computing is probably the most interesting, because in some sense it's the most open. And traffic, I haven't obviously thought about traffic engineering as one of those things, but I could claim that we have at least 3,000 years worth of some understanding of what roads look like and what traffic looks like, right? Going at least back to the Romans or the Chinese road systems. We have very little understanding of computational systems to augment the social world. So this is a great time to get into, to be studying it, I think. Yeah.
I was wondering about how the material differs from the technical, per se, and whether there's, in your sense, the technical is different from our relationships with the material world more generally, and how designers, say, create worlds within which people then live and work. And I was wondering how you would differentiate that, whether you would think of the technical as a subset of the material, or whether the technical is different because it's more fluid and somehow has qualities like the material would be limited, or things you can't do in the material, and how there might be things in the material world that we could look at that might be models of what the.
So let me come back to that in just a minute. So I have to say that I haven't thought a lot about that, but I'm just about to get into some of the work. So I think the pattern that I'm hearing is everybody's starting to think about what the science actually would include. And let me say a few things that what I think it includes. And then we can open it up, but let me at least get through the regularly scheduled portion of the show. Okay, so I'm actually just going to skip those. Oops, I'm apparently going to skip the rest of my talk. Pay no attention for a second. Well, that was the desktop version too. Okay, let me do this one instead. Anybody know Word in here? Just thought I don't know. Somehow I felt like I should say that. All right, I'm not going to be able to do this well just because I can't find the right slides, but let me say some of the attacks that I've taken on this. So I've been thinking about these problems and for a while, and one of the things, I guess we'll kind of scroll because this is Word, but is looking for support for people as they use privacy policies. So one of the questions is, what would some sort of augmentative tools to help people with privacy statements? And so one of the questions is, well, what would you need to actually help people in creating these kinds of computational systems? And this is work that I've done with Mark Newman and Atul Prakash at Michigan. One of them is Privacy Mirror, which is the ability to play sensor streams forward so you can kind of see what would happen. So, you know, in some more perfect world, if I release my medical data, what would happen in the future? And I could at least run it by some prototypical uses. And then the other part is something called privacy circles, which is I might not be very good about thinking about these things. And so I want to use somebody who is pretty good and who thinks about these things. Another attack on this is thinking about actually using the same architecture to rapidly scroll by, apparently. I think this is like the projection guy's nightmare. And this is to think about a set of memory infrastructure. Some of you have heard me talk about this in a separate talk, but my argument here is that the infrastructure of memory is actually changing. So how many of you have digital photographs? 10,000 or more digital photographs? Yeah, there's always a few. How many of you know every photograph? How many of you have put all the photographs in photo albums? That was kind of? Okay, cool. So, you know, the argument is that as we change the kinds of things that we can do, people's remembering will actually change. So I like to give this as kind of a thought example. How many of you have digital picture frame? Chris left a few. Wow. This is like a very innovative group, by the way. Okay, so if the argument that I would make is if you walked into my office right now, or you walked into your parent, you know, into a relative's house, and every picture in the room included you, that would just be creepy. In 10 years, if some picture doesn't include you, that would be rude. Maybe. Right? Because we'll have the ability to kind of do that. And if you walked into your parents' or some cousin's house and there was no picture of you, that would just seem kind of strange. Right? So this is a very simple example of maybe some of the ways that this is changing. The thing that actually interests me for the purpose of this is these are really interesting because these are very small resources. You can combine them very flexibly in your house. You don't have to change everything. We tend to create these enormous systems which don't work very well. And maybe there's some question. This allows a great deal of interpretive flexibility at the same time that it also allows combinatorial flexibility. I can mix and match things very easily. And this may be one line of attack that's very different than the kinds of things that you proposed. Right? It's just that I create small things that then can be combined. And this might actually be more socially advantageous than some of the larger solutions we've come up with. And so here's Facebook. And yeah, this is my son. Especially since it's going to be in the internet later maybe. But, you know, so one of the arguments I might make, and I'm just going to throw this out as a provocative argument, is that in some sense this is a small resource. I can combine it in ways that I find useful. Right? It doesn't have a lot of connection to other kinds of things. It's not a large-scale workflow system. It's just, it does what it does, and that's all it does. Hopefully, unless it's decided to disclose all of your data today. Right. And so, in some sense, it may be that one of the reasons that large-scale social computing systems work so well is that they can be combined very nicely by users. Okay. And then just to muddy some stuff up, I think one of the things that the science needs to include is an understanding of part of the contextual. So there have been some calls for a very empiricist view of this science. So we'll do experiments and understand how all people do things. And that's very provocative. I think in some sense, though, that there's a room for, maybe I should have called this artificial anthropology or something instead. This is a study that we just finished up last Friday, for those of you that know that particular deadline. And it's with Lada Adamic and Jiang Yang. And the idea is, you can barely see this, but this is called MIT BBS, which actually was the MIT BBS, but as you may have noticed, has mutated. And it's a bulletin board, it's a web board for Chinese students in the United States. And one of the things that's really interesting is they have a very small design feature, which turned out to be really critically important, and that was you earn virtual points. Has anybody used this in here? Okay, so you can gain virtual points by doing the standard kind of answering or posting behavior. But unlike on a lot of US systems, you can actually transfer those points between individuals. And that turns out to be really important to Chinese because they can now have this very ambiguously valued gift that they can give to one another in a very Chinese kind of way. So if you know anything about Chinese culture, you're probably familiar with guanxi, which is basically, there's no great translation, but it's basically the art of developing social relations. So one of the things that you do is you give little gifts to show how you're connected to other people, right? And virtual points are great because you can just give them to people as a little token of thank you for providing me with that additional information. Here's 10 points. 10 points actually doesn't mean anything, as it turns out. You can't really do anything with it except give it to other people, right? There's no exchange rate for it. And so one of the things that's really interesting is that this is a feature which probably actually wouldn't be that valuable in a Western setting, although there are systems that do this. But it turns out to be really interesting in a Chinese system. And then two more.
Like virtual goods.
Virtual.
Like virtual goods on, say, Facebook. You can send a friend, I don't know, flowers or something on their birthday as a, hey, thank you for being my friend.
Yeah. So one of the things that's more interesting about these is that it's an ambiguously valued gift, and it's a token gift in many ways. So I suppose you could say the same thing about virtual flowers.
So Facebook does cost money though, which I think changes even the gifts that you don't.
Okay. So the comment was it costs money, virtual money or real money?
Some gifts cost real money.
Okay.
$1.
Yeah. So that would be a difference here. You can actually buy these virtual points with real money from other people. There's a gray market in these points. But the value is like 15 cents a point, roughly. Yeah. Sorry. Okay. And then just another one to kind of point out some, I think, the similar contextual issues is we're finishing one on couch surfing. Any of you use couch surfing? This is where you, okay, a few. So this is a setting where you actually borrow someone's couch when you're traveling. My daughter did this in Europe. I found out about it after she had done it. And one of the things that's particularly interesting is it appears that the ratings of trust and friendship, we've done both quantitative and qualitative analysis, are very dependent on this group, right? This is a very trusting group of people, right? I'm staying in somebody else's house, right? They're letting me stay in their house. And so views of what it means to be a friend or a trust or in a trust relationship actually differ considerably from other kinds of systems like, say, Facebook. And I think it's important to understand kind of some of the contextual nature of this in the science. I think that this is going to be an important part of that science. And then one last thing to talk a little bit about materiality, although kind of virtual materiality, is that a term, is a study of a game mud. And what we were trying to do is look at some of the, what's it mean to actually do code? Right? So we kind of talk about the social world and computational mechanisms, but then there's, you're always doing this design in a computational medium. And we have some handle now on paper, but not necessarily on computational stuff. I'm not going to go into the full thing, but one of the things that's particularly interesting is that he actually did a study of a game mud and basically how the immortals look like police. They do something called, social regulation. And the idea is, it was actually a really great study because he got to talk to police, right? So what are police looking for? What one of them said is, we like to chase people around and then pop the trunk to see what's in it, right? That's what some officers live for. Well, systems admins don't get to do that. But what they do get to do is look through walls, which normal police can't do. Right? And one of the things that's particularly interesting is that probably that shouldn't be range, but the kinds of things that you can look for are very limited. They follow what Phil Agri calls a grammar of action. You have to program in specific kinds of things to look for. You can't just look for any behavior. And because these are such large-scale systems, that automaticity is really important. I think I'll just kind of end there. We're starting to zone out a little bit. So, questions, comments? That didn't actually completely answer your question, but that's as far as I can get. Yeah.
When you say it's a new science, and in my mind, this progression of science, of a particular science area through history, and typically, let's say biology, there's like a collection stage where they were just categorizing, and then, they came up with more rules, and Darwin was able to organize and start systematizing things. Where do you think you fit in right now with this new science? Are we still in that sort of categorizing collection stage?
Pre-Linnaeus. That's a great question. So the field has been criticized for doing one-site studies. The problem is that doing multiple site studies, I've had the unusual situation of being criticized for only having 20 million data points, which the ethnographer in me finds amusing. But it's kind of true. So I don't think we're at the point where we really understand the commonalities enough to do all this. At the same time, I think we are doing, it's a lot like anthropology. And so in the 1870s, anthropology was essentially an armchair field. You brought back travelers' tales and you kind of collected them and thought about what they meant. And between about 1890 and 1920, it turned into people actually going into the field and trying to find out kind of commonalities. So things like kinship patterns or exchange networks came out of that period. Exchange networks a little later. So I think that we're also kind of simultaneously there. So there are a lot of these underlying mechanisms that we're starting to uncover, I think, including about why it's important in one site as opposed to another site. Those things are really important. That's where anthropology, I think, started. That's why I said I think maybe artificial sociology is the wrong term. It may be artificial anthropology or something close to that. So I think I would say my fields are doing both at the same time. We're kind of in Linnaeus and past Linnaeus all at the same time. We haven't made it to Darwin. Yeah.
You said earlier that, in effect, it's great because you're creating these new worlds, right? But in effect, what I see, at least with research on social media, is you're always reacting, or almost always reacting to the world that's being formed. Like Facebook is creating culture. You're researching the culture that's effectively being adopted or generated by users who change after using Facebook. So that seems to be possibly a tenuous point. are the problematic. You're not actually creating these worlds or these applications. You're looking at the aftermath, right? How it changes people's behavior.
Well, there are at least 2 people in this room that have created their own worlds. So I would say that many people, I mean, one possibility is you create your own worlds and you get them out there, right? That's an enormous amount of work. So if you're in a university, you probably can't do that because you don't have the resources to really do it. There have been attempts largely in industrial labs to do that kind of thing. But yeah, that's a really interesting problem.
But which side do you focus on? Or do you always have to choose an aspect or?
You mean the social side or the technical side? I'm not quite sure what the two are.
Are you hoping to create these applications that form culture, or are you hoping to understand it?
Well, those that know me know that I don't make that choice. I think you do both. I think you might choose one or the other because that happens to be your gifts and the kinds of resources that you have, but I think you have to do both. Right? And it's not an easy understanding for the reason that you just pointed out. I mean, first of all, it's just really hard to do, but secondly, you've got this confound. So to push on my metaphor to death a little bit, it's like you're an anthropologist and you're going in and creating social change, something that they don't do, right? And then you're studying the people that are undergoing the social change.
But the challenge is that these are not discrete or bounded spaces. And so I think that the early stage, 1980s, 1990s virtual worlds were bounded spaces that could be understood in their own terms. There's no way to study Facebook at this point without understanding the networks of people as they move between a whole variety of different spaces.
Absolutely. So I presented MIT BBS as though it was a unified thing. It's not. It's, you've heard me talk about this in your meeting, but, it's Chinese in the U.S. It's Chinese students in the U.S. They're students in the U.S. They're in the U.S. They're also getting things. So, for example, one of the things I didn't talk about is the political discussions that go on there. They could never go on in China. They could only go on in the U.S., even though they're Chinese students in the U.S. Right, so what exactly the nature of this world is I think, open and contested. And that also is one of the interesting problems. Right, I completely agree. I'm not claiming this is an easy science. Right? This is not, we're not going to come up with the second law or whatever of thermodynamics, but tomorrow. Although if you do, again, I'll be happy to employ you as a postdoc. Yeah?
I'm going to slide in before the thermodynamics. As someone who thinks sort of first and foremost about the social and sort of secondarily about computing, I'm a little curious about what you think the field contributes into understanding the social. So when you think about...
So let me put it in, so I actually attended your talk, but virtually.
At Berkman?
At Berkman,
okay. Yeah.
So I'm not sure whether I should talk about attending your talk virtually. Is it something that adds to an understanding of the social? Or whether the e-government part?
All depends.
But, so one thing is, these technical mechanisms are intervention in the social world, or maybe the social world as it might want to be, or some set of alternative social worlds. And, this is I think Dana just pointed to this. It's not easy to bound the problem, right? So it's an understanding of the social world from putting a technical probe in, but it's not the social world that was, it's the social world that might be.
I guess I understand what you're saying, but I guess my question is more, there's an approach that says I'm interested in friendship and social networks, and I'm going to go out and look at social networks regardless of what forms and new spaces and new configurations that they take, right? So you can see how a study of Facebook might turn into that, might be included. But that's an approach that starts very firmly with the social and then asks the question about the technology. And I'm just wondering if that's sort of counter to like your very first slide, which I think talks about how technology can augment the social world, which is a very different approach. And I just want to make sure that that's...
Well, my particular interest is in design.
Yeah, okay. So it's about what you can build and make better in the world.
Yeah, but I think, this goes to the comment that I made about the infrastructure of memory, that infrastructures do change the social world.
Sure. Absolutely.
And I think people who don't see that and treat all infrastructures as identical are being kind of naive about the way the social world actually works. So I like Meyerowitz's statements about, communication mechanisms and the fact that the nature of the communication mechanism changes the communication itself. I think that's true about a whole range of social activities that we do through various technologies. Paper clearly does stuff. It has design properties. I would argue, this goes to the last slide I showed, code also has design properties.
I guess I'm pushing a little hard on this, but I mean, I think of it as when I teach about sociology and technology, you know, the first thing I always show are slides showing that, you know, in a relatively short period of time in the Western world, we're not really changing how many children we have, let's say post-World War II. That many of the sort of basic things that we think of as social actually haven't changed as much. The recent sort of sociological debate about how many friends and what social isolation looks, the numbers are small in terms of what contact means. So I'm just curious about whether social computing, how far it's pushing an idea that's away from continuity and more of an argument of change, which is fine and great and exciting. But I'm wondering if there's any room for the continuity part of it.
Well, I don't know whether I should invoke Peter Laslett's arguments about farm families or whether I should go to the continuity. So let me go with the continuity because that's probably more interesting to the audience. You know, that's a valid point. So especially sitting here at Microsoft, standing here, I guess, at Microsoft, you know, that we tend to privilege arguments of discontinuity and revolution in, you know, studies of computing. Whereas the social world does move much more slowly, although sometimes quite a bit. And I would still say that in many ways, you know, to go back to my original question, the things that make social computing so hard, not how do I change society so hard. The things about social computing is that it's this interplay between a social world that really has some interesting sets of rules that doesn't move that fast, doesn't just evolve like that. That there is kind of a, you know, to think about it in design terms, there are sharp constraints to it. And yet, they're not permanent. They do move in interesting ways. And then a set of computational technologies that are actually quite flexible to design, except extremely brittle in use. Right? And the interplay between those two is, I think, the thing that makes social computing really an interesting place to be. Yeah.
I was curious, I had never heard about end-user programming before. You threw that concept out earlier in your talk. And I'm curious about that. I mean, it seems like a fascinating possible direction for this world. And do you think it's possible for, you know, true kind of average end users to program their social networks in the same way that we can program culture using language or symbols now in the offline world? Is that a possible utopia for the field?
So I'm going to guess you're not an Excel programmer from the nature of the question you just asked, because that is a place where we do end-user programming, right? So we actually have a long history of that. And, you know, I admit that people probably don't program in Lisp or whatever, but they do, or
Facebook's events system.
Right, exactly. So there's been a whole set of research, not only in HCI, but actually in visual programming and some other fields in computer science, to look at how users themselves might tailor systems or change systems. And that actually has come back with the web with things like mix-ins and stuff, dashboards. Your question is whether we can do this as a utopia or whether this is a utopia, I guess. And you know, I don't have a good answer. I think this goes back to the nature of the inflexibility of computational systems. So the ability to describe what you're doing is essentially a formalized statement in some way, and that in itself is brittle. And the question that we're exploring with the policy stuff that we're doing is, can you provide mechanisms that will facilitate people's understanding of that programming, and then also create small enough things that they can flexibly mix and match rather than these enormous things that really reprogram their social world, which I don't think people are going to be able to do.
I think can I take up a response? Dan Perkel has written a lot about what he calls copy-paste literacy, and it was during the heart of MySpace element where people could copy and paste code and own those profiles. And what he was really interested in is how it changed your mentality as you related to the artifact. And what he found was that people who were taking all of this code, making a complete mess of it, making the worst of GeoCities pages you could imagine, felt a level of ownership and engagement that radically changed participation in social media. And so there's also this really interesting element of just like, when is it about achieving a certain technical affordance, or when is it about achieving a certain kind of social engagement level? And I think that one of the things I just really take from Perkel's work is that component wasn't really about the outcome technically, but the outcome in terms of relationship to the technical system.
Right, and people were starting to think, oh, it's just HTML, just in non-programmers.
If you want to know more about this, Mr. End User Programming is sitting over in the corner there. Andreas, you want to raise your hand? Yeah, you can talk to him. Any other last question? Well, thank you for coming.
Thank you.